Welcome to today's session. I'm Ava, and last week we talked about the data processing phase of the machine learning lifecycle.
Yes, welcome everyone. I am Aniakin. Yeah, today we're going to continue that conversation that we started on feature engineering, focusing today on feature transformation, feature creation, and we'll even touch on model training.
Oh, yes. So, in the last episode, we introduced feature engineering and talked about the art and science, really, of selecting features. And what did we say about features? They're essentially any measurable property or characteristic in your data.
Yes, exactly. We said that we should think of it as an ingredient that your machine learning model uses to make predictions.
Right, that's right. So, for example, if I have a spreadsheet about customers, columns like age, income, or your favorite color, each of those would become a feature, correct?
That's exactly right, Seva. Features come in many forms, right? If your data is text, features might be words. If it's images, pixels or texture might be features. And for audio, features could include different sound frequencies.
That's right. And we also discussed why feature engineering is needed. Raw data often has issues. It could be missing values, extreme outliers, or even skew distributions. And this makes it tough for the models to learn effectively.
Yeah, and that feature engineering helps fix these issues, making data cleaner and easier for models to understand.
Yeah, that's great. So let's go ahead and explore some common feature transformations. What is that first?
Yeah, we're going to look at logarithmic transform, right? Imagine income data where most people earn anywhere from between 50,000 to 100,000 or 90,000. However, there are a few millionaires, creating a skewed distribution.
That's right. Those extreme values can dominate the model. And this reminds me of the Bill Gates house example I shared in a previous episode as well.
Yes, that's exactly right. And also by applying the log transform, huge values, right, get compressed. It stabilizes variance and makes the data easier for a model to handle. AWS Glue Data Brew and Amazon SageMaker Data Wrangler let you do this visually, no coding required. All right, now that we understand log transform, let's look at another important transformation technique called polynomial features.
Oh, yes. So those are also available in SageMaker Data Wrangler. And it's going to help models capture relationships that aren't just straight lines, right, Aniakan?
That's right, Eva. Imagine predicting house prices based on size. Sometimes the prices don't just go up evenly. Very small or very large houses can have special pricing patterns, creating a polynomial feature like size squared or even size cube helps the model understand those nonlinear relationships.
Yeah, and again, SageMaker Data Wrangler makes this just a few clicks away. There is
Mhm.
another one. It's a bit of a tongue twister, Box Cox. That's one of the little more advanced ones, right?
Yeah, that's right. It transforms your data to make it more like a bell-shaped curve, right? Think of it as tuning your data. It uses a parameter called lambda to adjust how your data gets stretched or compressed to become more balanced and predictable.
When you say tuning your data, are you referring to making the data distribution more bell-shaped curve or normal distribution also as it's known?
Yeah, that is exactly right, Eva. Data that is bell-shaped or normal helps lead to more stable, more linear relationships and reduces outlier impact.
Great. So now we're done with transformations. What about creating new features?
Yeah, feature creation. So that is making brand new features from existing data. Many real world features are categorical, like color preferences or education level, and must be encoded numerically.
Yes. So, in other words, models need numeric data, and so we can convert those categories into numbers by encoding them.
That's exactly right. And one way to do that is with one hot encoding.
Oh, yes. Yeah, we talked and actually saw one hot encoding last week. It's simple. Each category is going to get its own feature. Mark with a 1 if it's present or 0 if it's not present. So if you have the colors red, green, and blue, one hot encoding is going to create 3 new columns. And let's say if you have, red is going to be 1, and then the other two are going to be 0.
That's exactly right. So a feature like, let's say, basic color names like these is considered nominal categorical data. That is, data that has no natural order. Red, for example, isn't more or less than blue, for example. And yes, Glue, Databrew, AWS Glue, Databrew, and SageMaker Data Wrangler can do this visual analysis for us.
And what if the categories have a natural order? For example, education levels, there is a natural order to them.
Yeah, that's a good one. Education levels. Education levels is an example of ordinal encoding, right? Assigning numbers based on their ranking, right? For example, we may say high school has encoded as one, bachelor's degree encoded with two, master's degree three, and doctorate degree four. And again, AWS tools make this easy visually.
Yeah, and this is another reason if you're working with data, you need to spend a little time getting to know and understand your data. To your point, Aniek, is the data ordinal or nominal? You want to be able to make good decisions there. And do you have any other encoding techniques to discuss?
Yeah, definitely. We can talk about label encoding. So, label encoding simply assigns each category a unique numeric value, like red is 0, or green is 1, or blue, 2, right? It's simple. However, we definitely need to be cautious about this because this can accidentally suggest an order that actually does not exist.
Aha, yeah. So it's best to use label encoding with tree-based models such as XGBoost, which doesn't assume numeric order. Now, we also have to talk about something else here. Let's discuss also continuous data, Aniakan.
Yes. Yeah, absolutely. Continuous data, that's about binning, right?
Mhm.
For continuous data.
Yes, that's right. For example, age, as we mentioned, is already a numeric, so we don't need to encode it. But then we maybe want to create categories, like for the ages, we can have a bin for young, middle-aged, and old, and so on. And so handling that data this way may help reduce noise from the outliers and help models find nonlinear patterns more easily. And yes, DataBrew and Data Wrangler have built-in binning transforms. In fact, I think we saw some in our example with Data Wrangler last week.
Mhm.
Great. Um, yeah.
Yeah.
So there are also two main binning methods to mention. So we have here equal width, where each bin is going to cover the same numeric range. And then we have equal frequency, where each bin has roughly the same number of records. Uh, Also, don't forget that we can store these features in the SageMaker feature store, right?
Yeah, Feature Store. That's Feature Store is a good tool, a great tool. We mentioned that briefly last episode, right? It's used to keep our features consistent from training through production.
Absolutely. Great. So let's go over some quick exam tips for feature engineering, folks. Understand clearly each type of transformation. Why do you use them? And remember the AWS tools that support those methods. And I think this foundation is going to could help you pass the exam confidently, right? So
Can
to
help,
just
definitely.
yeah, agreed. Maybe to just go over those one more time here. So we have the log, polynomial, and the Cox box transforms. Know when and why to use each. And then we have one hot, ordinal label, ordinal and label encoding. And then you want to understand the pros and cons of using those. And then we have equal width versus equal frequency for binning. And you want to be able to match each of these tasks with the right AWS tool.
I love it. Yeah, those are great highlights, great things to think about and to study for the exam. Thanks, Ava.
Great, absolutely. So now that we have covered feature engineering, let's dive into another critical component of the machine learning lifecycle, and this is going to be the training phase. We are finally here. So, in Yekan, where does the training phase fit in the overall machine learning lifecycle?
Yeah, great question. Yeah, so after data collection, pre-processing of the data, and feature engineering, training is where algorithms learn patterns from your prepared data.
And for the ML Engineer Associate exam, candidates need to understand how to select the appropriate algorithms, configure hyperparameters, and also evaluate model performance, right?
That's exactly right. The exam tests your ability to pick deployment infrastructure, scripted and automate deployment, all of which relates to how we train and implement our models.
Great. So let's talk about the key AWS services for model training that the exam candidates need to know.
Yeah, Amazon SageMaker, right? A flagship product for machine learning. So this is AWS's fully managed machine learning service. It handles the entire ML workflow, including powerful training capabilities. Know its distributed training options. Know hyperparameter tuning jobs, built-in algorithms, and in addition to the built-in algorithms, know that you can also bring in your own custom algorithms.
Yeah, that's actually a great point, and it might come up on the exam. And also, don't forget we have SageMaker experiments for tracking training runs and SageMaker debugger, which is going to be used for monitoring training progress and also debugging potential model issues.
That's exactly right. And then there's the hyperparameter optimization. So this is a critical concept for the exam as well. So Eva, can you explain what that involves?
Sure thing, Aniakan. So hyperparameters are the settings we choose before the training begins, like the learning rate or the tree depth. And unlike the model parameters, they are not learned during training. I think of them as levers that you can turn to, um, use them to basically fine tune your model with hyperparameters.
Nice. And SageMaker provides automated hyperparameter tuning capabilities, right?
Oh, absolutely. SageMaker hyperparameter tuning uses techniques like Bayesian optimization or random search to find the best hyperparameter configuration. And this is going to save data scientists and ML engineers significant time and is going to improve the model performance.
Wow, very cool. And I'm getting excited because I think it's actually time for a demo, Eva.
Oh, is it demo time? All right. So, since you mentioned it, Nyakan, let's go ahead and let's take a look at our demo for today. So, let me share the screen here and we'll talk all about using the XGBoost algorithm to fine tune a model. So, this is what this demo is about. And then, Nyakan, could you confirm, please, that you can see my screen okay here?
I can. Looks great.
Great. Okay, so here, folks, we are inside the SageMaker Jupyter Lab, and I have a notebook here that I have opened, and I have ran some code. I ran it ahead of time because it does actually take some time for some of those steps to complete. But I will walk you through one by one. So first here in the first cell in my notebook, I'm importing the necessary packages, and then I'm setting up my SageMaker environment. And I'm going to use for this particular example the popular XGBoost algorithm. which is going to be training also the popular abalone dataset. This is a dataset that I'm going to download from the from university website here, and then I'm going to be using it for training. If you're not familiar with the abalone dataset, it's going to predict the age of the abalone based on certain of their characteristics, right? So we're talking about a regression model here. Spoiler alert. Great. So you can see the output here from running the cell. And again, this was downloaded. And now I have this available in my S3 bucket to work with. Great. And then I'm going to do some transformations here to be able to change the format of the abalone so I can work with it. And then the next cell here, I'm going to split into training and testing data. So I'm going to have a 20-80 split. As you can see, the test is going to be 20 and the train is going to be 80. And this is pretty characteristic there. Great. After this is done, I'm going to prepare test data for later use. And so there's just some basically formatting and things like that to deal with, kind of a bookkeeping details. And then the next is going to be to train the XGBoost model. So I'm retrieving the model, the container here with the model XGBoost again, and then I'm creating an instance of the SageMaker estimator object. This is going to allow me to configure different things like the instance type. And look at it here. We just talked about hyperparameters. So you can see some examples of hyperparameters right here.
Very
And
cool.
they're going to be set in place here.
Yeah.
Yeah,
And
and
one
then
other thing, I'm
yeah,
seeing the number round is 100. What is that? Is that what does that mean? No.
yeah, that's a great question, Riakan. And another term you might hear for this is going to be the epoch. So this is going to be the number of iteration that is going to go through in the training. Yeah,
So
great,
this
great
is
call
so
out.
that is set as a hyperparameter before the training even starts to indicate how many iterations, how many epochs he said we need to go through for this model training job. Okay, cool.
Yeah, absolutely. And then we're
And
going
sorry, one
to,
more thing.
yeah, yeah, yeah,
If you
sure.
scroll back up a little bit, okay, so these hyperparameters, these are hyperparameters specific to this particular algorithm, right? XGBoost, right?
That's right. Yeah.
And
So
different algorithms might have different hyperparameter settings.
that's a great observation, and that is exactly correct, Aniakan. And yeah, you should know this. So these are specific here for the XGBoost algorithm.
Okay, cool.
Absolutely.
Yeah, thank you.
Great. Yeah, great questions, great call outs. Okay, and then I'm going to get my training input, which is the data stored in my S3 bucket here. And then I'm going to start training. So when you call the fit method, it's going to start training. And then I'm going to scroll here. There is a lot, but these are basically all the training steps that it goes through. And those are interesting to look at for sure. So it's going to continue training. Sorry about all the scrolling down to from 0 to 99. So that's how we get to the 100. And then it says how many seconds it took. So the training job completed. Great. And at this point, if I'm happy with the results, I can also deploy the model. So here I'm deploying the model. And now I can start using it to do what, Ani? I can make predictions, right? I can now start making predictions here. So here are some metrics that are calculated for this particular model, folks, and those are specific to the fact that this is a regression model. So these are metrics relevant again to regression models, and they look okay. That probably needs more work here, but I'm just more focusing on the sequence here, on the the workflow. And one other thing you can do that is always helpful is going to be to visualize the predictions. So a couple charts here. Here we have a scatter plot chart of predicted age versus actual age. So you can see how that goes. And you can also visualize the residuals. So this is going to be, you want this to be fairly randomly distributed. And this is what is going to give us the residuals versus the predicted values. So the actuals versus the predicted values. And then always the best practice is going to be to delete the endpoint, clean up the resources so you can don't incur any charges that you don't need to incur. That's all I have here. Maybe just to summarize again, what we showed here is that I can use the XGBoost regression model with SageMaker, and then I can train using this XGBoost with a custom dataset, in this case, the abalone dataset.
Hmm. Very cool. That is wonderful, wonderful demo as always. Thank you, Ava.
My
And
pleasure. Thank you. Yeah.
yeah, you're welcome. And yeah, so that's it for this episode, everyone. Thank you for joining.
Yeah. Thank you, everyone. Thank you for liking and subscribing, and we'll see you next time. Happy studying. Happy
Yes,
preparing for the exam.
yes. Thank you, everyone. Bye.
Bye.